Now, for our last example, we will be looking at a more challenging question. So, we have an atom that contains 5 electrons in its M shell. What would be its atomic number? So, at first glance, this may seem like an impossible answer, but really, it is quite simple. Let's get to it. We already know that the atomic number is the same as the proton number. The proton number is identical to the number of electrons in an atom. So, if there are 5 electrons in the M shell, this must mean that the K shell and the L shell has been completely filled. The K shell has a maximum of 2 electrons and the L shell has a maximum of 8 electrons, since both the L shell and the K shell need to be filled for electrons to occupy the M shell. The answer is simple. 2 plus 8 plus 5 equals 15. So that means the atomic number of this element is 15. Let's also take a look at the number of electrons in the subshells. The answer is pretty simple. 1s2, 2s2, 2p6, 3s2 and 3p3. Let's wind up this video with this quick reminder. Remember, the number represents the shell number and the letter represents the subshell. For example, for the first one, 1 would be the shell number and S would be the subshell. The superscript of power represents the number of electrons that the subshell can hold. Here's the sequence in which electrons fill in the subshells. Once you add all the subscripts, you should get the total number of electrons in an atom, or in other words, the atomic number. You can look at this table and see different electronic configuration of the first 18 elements. You can see that the atomic number increases as we go forward in the periodic table. The number of subshells also increases as the number of electrons increases. So, I hope after this lesson you would be able to do electronic configuration on your own.